Hello everyone. So today we'll be discussing with respect to the strain gauge load cell with respect to sensors and transducers. So we will be discussing how the load cells will be used. Uh, we'll see with a small derivation with respect to that. Okay, let us see that. Yeah. So strain gauge here, if you look at that, the strain gauge is nothing but the load cell, so which are being used as a load cell. So basically, these cells convert weight or force into the electrical output, which are provided by the strain gauges. So basically, what happened here, the load which have been given, the mechanical input, so which will be of in the terms of mechanical load in the form of weight or force, so that can be converted to the electrical output. So basically this force, so it could be any mechanical input can be here. So right now we have been taken as a weight or force. And coming to the output part, the output can be measured, the electrical output can be connected, or it could be measured with respect to different measuring instrument, or recording or controlling the weight or force here. So basically there are many measuring devices are available where we can convert this mechanical input and to the electrical output, then we can record the electrical outputs over here. So if you look at here, right now, so these instruments will be used for indicating what is the input or force which is given in terms of electric or mechanical. So that will be connected to the electrical output, and the appropriate the electrical output signal will be measured, that will be proportional to the mechanical input. That could be the force or it could be a mechanical weight. So that is how it will be shown. And different devices also available. CROs are there. The CRO is also one of the best devices to record your electrical output. That is also possible here. So coming to this construction and working of the load cell here. So basically this is a cylindrical type device which you can see here, and the mechanical input or the mechanical force or load which will be applied vertically, where you can see here. So that will be applied vertically on the cylindrical, and we make use of a four strain gauges here. Right now you can see RG1 and RG4, which are vertical with the load, that is a mechanical load which is a vertical, which has been placed vertically with the load, and two more devices, strain gauges, you can see that RG2 and RG3, which will be connected in circumference to my RG1 and RG4. So basically four strain gauge load cells are connected. So these four strain gauges are connected in the form of a Wheatstone bridge, which you can see on the right hand side. The four arms of the bridge which is used to connect these strain gauges, and which will be given with a supply. So whenever the bridge is in a balanced condition, if there is no mechanical input, so all the resistance value will remain same, and hence output voltage will be 0. Okay. If the force is applied, the resistance of this strain gauges will vary. So based on that, the output voltage is going to change over there. That output voltage will be proportional to the mechanical load which have been applied there. So this output voltage will be proportional to the mechanical load or mechanical force which has been applied there. So it will be proportional. So this is how it will be measured using my Wheatstone bridge. Let us see a small derivation with respect to that. So this is a construction working of the load cell here. So as I mentioned, all the resistance will be having with the same value, RG1, RG2, RG3, RG4, all the strain gauges has the same resistance value. And if assume that if there is no mechanical input, obviously the bridge is in a balanced condition, because there is no change in the resistance with respect to all the four arms of the bridge over there. So now if I take a terminal B and D over there, where the output voltage is 0. So because as I mentioned, there is no change in the resistance happening with respect to the strain gauges. Hence we can say that the output voltage is 0. All the resistance are with the same value, there is no change in resistance, output voltage is 0. So another case, if there is a load, okay, and applying a load, because of that load what happens, the resistance value is gonna increase here. The resistance value is gonna increase or it could be decrease here. Both are possible, whether it is in a compression or it is in a tension. So based on that, if the resistance is in a compression, so what happens here, the resistance value will decrease. If it is in a tension, the resistance value will increase. So in the both the case, in a compression and tension, what happens, the resistance value of the bridge is going to change. Based on the resistance value, if it is imbalance condition happening, the output voltage measure will be proportional to the force which have been applied. So based on that, we can conclude with the equation which you can see in the next slide. So with respect to this compression tension, how it's going to happen. So when the compression happens, what could be the equation? Here are the equations here. So at a terminal B, if you look at that, the VAB is equal to Rg1 divided by Rg1 plus Rg3. So where Rg1 is nothing but the change in the resistance which is happening when the load is applied. When the resistance changes, that it can be written as, we can replace by R minus dr. Similarly, in the numerator, denominator also, I can replace Rg1 with respect to R minus dr. And Rg3 I will be writing as a R plus mu into dr. Mu is nothing but my Poisson's ratio there. Similarly, for terminal D also can be written, where Rg2 divided by Rg2 plus Rg4. So where Rg2 is equal to your R plus once again mu, that is a Poisson's ratio, dr divided by R minus dr. So this tension and compression can be replaced with respect to Rg1 and Rg2 for the both the strain gauges, the load cell. So finally we'll get that equation, where this equation will indicate that the whatever the force you have been applied, the force is proportional to the output voltage. Okay, thank you.